Happy 2021, my aspirants. Hope you do great in your exams.
Fucking with all these money don't count itself. Always be counting on.
Guys, welcome back to today's video. Today we are going to solve the questions which appeared in 2002 calorimetry and heat transfer chapter, right? So let's begin with the first question. The first question reads as: heat given to a body which raises its temperature by 1 degree Celsius is. The options are water equivalent, thermal capacity, heat, specific heat, D is the temperature gradient. So before solving, I would like you all to first answer the question. It's a very simple question. You can see it's like definition only. So after you have solved, let's go to a detailed solution, right? We all know the definition of specific heat. Specific heat we all know. From the foundations only we are studying that the specific heat is the amount of heat. What is the specific heat? It's the amount of heat, right? Which raises the temperature by 1 degree Celsius, which raises the temperature by 1 degree Celsius for unit mass body, of a unit mass body, right? Of a unit mass body. So from here, specific heat is, the definition of specific heat is this. So from very clearly, C option is not going to the option. C option is not going to be the right answer. Now we all know the total heat is given by the formula ms delta T, right? Ms delta T. Now if T is equals to 1 degree Celsius, right? If T is equals to 1 degree Celsius raised by 1 degree Celsius, so if T is equals to 1 degree Celsius, therefore Q is equals to ms, right? That is the thermal capacity. That is the thermal capacity. The thermal capacity. So amount of heat required to raise the body, amount of heat is required to raise the body by 1 degree Celsius. So the amount of heat to raise the body temperature by 1 degree Celsius is called thermal capacity, right? This is by definition only. So answer B is the right answer. Otherwise, so the second question which appeared in the calorimetry section in 2002 JEE mains is: if mass energy equivalence is taken into account when water is cooled to form ice, the mass of water should be. Option A is increase, option B decrease, option C remains unchanged, option D first increase and then decrease. I would like you all to first try this simple question and then go for the solution. With the hope you have tried by pausing the video, I am going for the solution, right? Answer: the mass energy equivalence formula is given by E is equals to mc square, the famous Einstein equation. We all know that this is the mass energy equivalence. Mass energy equivalence means in simple term ऐसा इक्वेशन जो मास को एनर्जी में कन्वर्ट करे, राइट? मास एनर्जी इक्विवेलेंस. नाउ द कंडीशन, अब वाटर आइस में कन्वर्ट हो रहा है, वाटर इज कन्वर्टिंग इनटू आइस, मतलब some water is converting into ice means some latent heat is given to the surrounding, right? Some latent heat will be given to the surrounding, which is responsible for this change of state, right? We all know that during change of state the latent heat is given, which does not rise the temperature but it helps in changing the state. So latent heat is given. Now latent heat, we all know, is a form of energy, definitely, right? Now if energy is coming out, so if energy is coming out means energy is decreasing, so definitely mass must decrease because E is directly proportional to m, as C is a constant which is the speed of light. So the right answer is option B, which is mass is decreasing. Thank you so much. Hello guys, welcome back to the third question, which is the question from the section heat transfer which appeared in 2002 JEE mains. The third question reads as two spheres of the same material have radii 1 meter and 4 meter and temperatures of 4000 Kelvin and 2000 Kelvin respectively. The ratio of the energy radiated per second by the first sphere to that by the second is. So the question is asking the ratio of energy radiated per second, right? With the hope that you have tried, I am going for the solution, right? Answer. By Stephens Boltzmann law, Stephens Boltzmann law, we know that P is equals to dq by dt, right? Which is sigma E at to the power 4, where E is the emissivity, A is the area, and T is the temperature, and sigma is the Stephens constant. Now P is nothing but the dq by dt, that is energy radiated per second, right? So P1 is equals to E sigma 4 pi R1 square T to the power 4. We have done nothing but we have expanded the formula of area, which is 4 pi R square, and P2 is equals to E sigma 4 pi R2 square T to the T2 to the power 4, right? Now for the ratio we have to do P1 by P2, which is R1 to the R1 square T1 to the power 4 by R2 square T2 to the power 4, right? Now by putting the values, we know 1 square to 4000 to the power 4 by 4 square into 2000 to the power 4, right? This is cancelling, will get 256 by 256 is equals to 1 by 1. So from here we can see option A is the right answer, right? So with this we are ending a very simple question. Thank you so much. Hello guys, welcome back to the fourth question, which is from the heat transfer section which appeared in 2002 JEE mains. The question reads as infrared radiations are detected by A spectrometer, B pyrometer, C nanometer, or D photometer. This is a theoretical question. For answering this, there is only one right answer, but I would be telling you all the functions of all these instruments. So starting with spectrometer. After I tell you the function, it will be very easy for you to select the answer if you don't know it, right? Spectrometer is used to analyze what? Yes, it is used to analyze EM radiation spectrum. EM radiation spectrum, right? Now the second is the first is spectrometer. B is pyrometer. What is pyrometer? Pyrometer is used to measure thermal radiations and infrared radiation from hot body, and infrared radiation, thermal radiation, or more specifically infrared radiation from the hot body. By now I think you have guessed what is the right answer, right? C is nanometer. What is nanometer? Nanometer is used to measure small dimensions. So definitely this is not the answer. I think you have got the answer, right? D is photometer. From the name only we can derive that this is something with light. Yes, it is used to measure light intensity. Used to measure light intensity. So I think I have made it very clear. So which is the right answer? It is the B. Pyrometer used to measure the thermal radiation and infrared or the infrared radiation from the hot body. So सही आंसर है ऑप्शन बी pyrometer. Thank you. Hello guys, welcome back to the fifth question, which is also a theoretical question which reads as, which is more close to a black body? Options are A. green leaves, B. blackboard paint, C. black holes और D. red roses. So आपको कौन सा लगता है, कौन सा होगा? ए ग्रीन लीव्स होगा, ब्लैक बोर्ड पेंट होगा, ब्लैक बॉडी ब्लैक होल होगा या फिर रेड रोजेस होगा, राइट? So with the hope that you have tried and you have an answer in your mind, I'm going to say first by the definition of a black body. What is a black body? Black body is that body which absorbs all the radiation, which absorbs all the radiations incidented on it and emits maximum radiation from it at a specific temperature. So from this definition we have to look. Now green leaves, something we see that suppose this page or this pen is white because, or suppose why it is white in color, because it is reflecting all the light which is falling on it and absorbing neither of the light, right? If it is black, we are saying why it is black, because it is absorbing all the colors that is incidented on it. It is blue because it is absorbing all the colors. All the colors means the colors which are there present in the Vivgyor, we all know from the very initial years only, and reflecting the blue light. So it is blue in color, right? Now from here green leaves, because it is absorbing all the colors and giving out the green color, so it is green in color. So this cannot be a black body, neither the red rose. The explanation is the same. The confusion is between blackboard paint and black hole. तो इसमें से कौन सा होगा, black hole या blackboard paint? Now going with the black hole, which many of you may have answered, but black hole में क्या होता है कि वो हर तरह का रेडिएशन एब्सॉर्ब करता है, पर ऐसा नहीं होता कि वो हर तरह का रेडिएशन एमिट करता हो. ये हमें नहीं पता कि वो that it emits all kind of radiation, but definitely it absorbs all the radiation. So the most probable answer is blackboard paint, right? कि वो हर तरह का रेडिएशन एब्जॉर्ब करता है. It is not 100% black body, but which is more close to a black body. तो वो हर तरह का रेडिएशन एब्जॉर्ब करता है और हर तरह का रेडिएशन एमिट करता है. हर तरह का नहीं, बट मैक्सिमम वो करता है. So option B is the. Oh, before writing that option, I want to mention something that you might be thinking that why I make such short videos like of 10 minutes or 12 minutes. जहाँ पे किसी का videos तो around 30 minutes, 40 minutes, they extend it. But I can cover maximum of the questions in 10 or 12 minutes. I take maximum of 2 minutes of your precious time. Before ending the video, I will be taking the 2 minutes and I'll be discussing this. I generally take 2 or 3 minutes maximum for each question. I know that when I was an aspirant, I know that the time is very precious for you all, and when you see that in the long videos, it only gives you a tension that will I be able to cover it? Will I be able to cover all the questions and see for the solutions? That's why I take minimum time so that आपका help हो और कुछ नहीं. हाँ, so very clear from this, nothing more. So very clear from this definition that option is B, which is more near. Black body क्यों नहीं होगा ये आपको समझ में आ गया. So with this hope, I would like to ending the video on a good note. Thank you all.